Welcome back to our physics class. This week, we learned about the third law of motion. On Tuesday, you answered the Lesson 3 word storm in the science textbook. What is the hidden message in that activity? Yesterday, you read the references and watched the video about the third law of motion, which we'll discuss today. Tomorrow, you will answer the guided generalization based on another minute-to-minute game. Make sure that your Newton's Olympics gains are already approved. Our learning targets for this week are the following. I can infer that when a body exerts a force on another, an equal amount of force is exerted back on it. I can generalize that Newton's laws of motion influence the design and implementation of Newton's Olympics. After achieving all learning targets, we will have our formative and summative exams about net force and the laws of motion next week. Before we proceed, let's recap the first and second law of motion. The first law of motion is the law of inertia. It helps us explain why objects resist to changes in their state of motion. Knowing that objects in motion have the tendency to be in motion, innovators came up with the safety features we have today, like the ones in the car. Can you identify one of these car safety features? On the other hand, the second law of motion is called the law of acceleration. This law tells us the relationship of acceleration with net force applied and mass of an object. Based on this law, can you tell how designers innovate high-performance motorcycles or race cars? Now, let's proceed to the third law of motion. This law tells us how two objects interact. Hence, it's called the law of interaction. Let's read its statement. For every action, there is an equal and opposite reaction. Action and reaction forces are equal and opposite in direction, but they are not balanced forces. In this Venn diagram, you can read that action and reaction forces act on different objects. Force of object A on object B, and force of object B on object A, while balance forces act on different objects, just like gravity and support force on a book on the table. Can you give examples of action and reaction forces? When you sit on a chair, what are the action and reaction forces? When you sit on your chair, the action force, your body exerts a downward force on the chair. The reaction force, the chair, exerts an upward force on your body. Another example, flying. The action force, the birds push down on the air with their wings. Reaction force, the air pushes their wings up and gives them lift. Third example, motion of a car. The action force, the wheels push the road backwards. The reaction force, the road pushes the wheels forward. Last example, the reaction of a rocket. The action force, the hot gases push against the inside tube of the rocket. The reaction force, the rocket pushes the hot gases downward. Let's try to identify action and reaction forces involved in the interaction in the given pictures in the next slides. Identify the action and reaction forces involved in the picture below. Number 1, pushing the wall. Action force, the lady pushes the wall, while the reaction force, the wall pushes the girl. Identify the action and reaction forces involved in the picture below. Jumping on a trampoline. The reaction force, the girl pushes down on the trampoline, while the reaction force, the trampoline pushes up on the girl. Let's demonstrate the law of interaction with the side builder activity, balloon-powered toy car. Why does the car move forward when the air from the balloon attached to it was released? What are the action and reaction forces involved in this demo? Action force, the balloon pushes the air out. Reaction force, the air pushes the balloon forward. As we end this lesson, let's reflect on the golden rule. Do to others whatever you would like them to do to you. This is the essence of all that is taught in the law and the prophets. This is from the Gospel according to Saint Matthew, chapter 7, verse 12.